Hi, I'm going to share with you my machine learning project that's a SmartFlow UX, an AI-powered UX issue detection and prioritization. So what the project entails as problem and task analysis would be that UX designers spend significant time manually reviewing user recordings, heat maps, and analytics dashboards to identify friction points. This process is usually slow, inconsistent, and often misuses subtle patterns, especially across large user bases or design systems. The key task of this would be to automatically detect and prioritize UX issues in digital interfaces from behavioral data, clicks, scroll depth, everything that we do review nowadays, and even further, and suggest actionable improvements. The idea is that we collect behavioral data, detect the friction patterns, and rank by severity and frequency. We will generate fixed suggestions with a machine learning model, and a designer will review it and decide to apply or which apply. A key insight in here is that the ML can compress 2 or 4 steps from days of manual review to near real time, removing subjective biases and surfacing systemic issues designers might overlook sometimes. About the user experience design, we will have user inputs and feedback loops, transparency and the model, and communicating uncertainties. The idea is that nowadays we do connect with things and tools for analytics like Hotjar or Google Analytics 4 via dashboard integration, and we have to continuously ingest anonymized behavioral streams to the ML so that after reading all the data, the model can each offer a suggestion, and the designer will be orchestrating, deciding to accept, reject, or flag anything needed, creating a reinforcement loop that personalizes prioritization over time. About the transparency of the model, each flagged friction point display the contributing signals, like 70% of users abandoning each step, or dropout rates and such. And so we can inspect which data drove that recommendation, so that there is explainability and transparency in here. And so the model has a stronghold on communication with us. And the communicating uncertainty will also predict or carry a confidence badge between tagging high, medium, or low confidence items that are visually de-emphasized and labeled with something needs validation when the system auto applies changes, or even it surface ranked suggestions that designers approve, always keeping the human in the loop and the human in control. Now, sorry, talking about the privacy considerations, we have data privacy concerns. Behavioral data will be mainly for gestures like clicks, scroll paths, and mouse movements that can indirectly reverse sensitive attributes such as health conditions or political orientation that may be biased too. The sessions recordings may inadvertently capture passwords, credit card numbers, or PII entered by users, so that should be something we have to care about. And cross-site behavioral profiles, like really identifying individuals even without direct identifiers when we're checking anonymous testing or even form filling from users, and data retention, storing raw session data a long time applies or exposure if breached. And on some of the applicable privacy labs will be for the United States, the GDPR, that lawfully basis for processing, and risk frameworks as the AI risk management framework. From there and from NIST, in the United States, there are also a lot of different laws by federal states, so that should all for sure be something that we might have to caveat. Um, when approaching this model in distinct states. For CA, we can have the CCPA and the CPRA right to the out of cell sharing, because we might be using notice at collection or no discrimination for output out. In Brazil, we could be having issues for consent or legitimate interest required, data subject rights, and DPO appointment if large scale. And in Mexico, particularly, we have a privacy notice, consent rights of access, curation, and cancellation opposition, like ARCO. For the ethical considerations, we might have potential sourceness or bias because we're sampling a lot of information. So sampling bias, maybe training data may overrepresent high traffic desktop, Western use segments, and such. Majority reference bias should also be from patterns from majority user groups that may eclipse edge case usability issues affecting minority groups. And historical bias, mostly for past design choices baked into training data that can reinforce existing friction rather than surfacing it as a problem. And what we will be taking account so that we fix this and keep a good track on what not to do would be fairness, to segment performance metrics by device type, geography, and user demographics. That these are actually pretty much defined and also included in the database from the analytics tool that we're using, and in accountability that all model recommendations are logged with a version, confidence score, and the data snapshot, and also the accountability for the designer who accept or reject anything to do. And include quarterly audits review acceptance patterns for systemic bias and anything that may be improving there for design-wise trends. And for transparency, an open model cards document training data sources known as limitations and performance benchmarks, and even the future importance explanation. The idea is that we have explainability there too, so that even if the model makes it all, we can explain it with our own words, and the user can opt out of behavioral collection. That would be the idea of the project. If you have any feedback, I'll be glad to receive it, and thank you so much for reviewing it. Yeah. Mandem.